Yes, Anisha, good morning.
Good morning, sir.
Yeah, we are good to go.
All right, we'll begin with the session.
Yeah.
Hello everyone. Good morning to all. Dear authors and invited guests, welcome to Technical Session 10D. Myself Sirali God and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communications Technology for Sustainable Development, ICT4SD 2026, Goa, India. The 11th edition of the conference is being held organized in a hybrid mode. The physical event is being held today on the 11th of July 2026 in Goa, India, and the virtual event is being held from Zoom from 9 to 11 July 2026. I hope you will enjoy this knowledgeable and interactive session through the day. In this session, we have a total of 10 presentations. Each presenter will be given 10 minutes for their presentation and 2 minutes for question and answers. On the 9-minute mark, I will raise a gentle reminder. There is another request to all the participants that you stay connected with us till the closing remarks. If you have any query or any update, please feel free to write to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for this session. Dr. Yogesh Mali. Dr. Yogesh is the Research Dean at Ajinkya D.Y. Patil University, Pune, India. With 15 years of academic research experience, he specializes in cloud computing, machine learning, artificial intelligence, big data, and the Internet of Things (IoT). He is actively involved in advancing research and fostering innovation in emerging technologies. Welcome, sir. And before we start, would you like to share some words with us?
Yeah. Yeah, very good morning to all the participants. I wish you all the very best. And let's start the proceedings.
Okay. Thank you so much, sir. With our first paper, we have Jayant Disiyanke with the paper title An Integrated AI-Driven Framework for Early Prediction and Ward-Level Surveillance of Antimicrobial Resistance. Dear presenter, you may start presenting.
Hi everyone, let me share my screen. Is my screen visible?
Yes, sir.
Okay, thank you. I'll begin my presentation. Hi, good morning everyone. It's a great pleasure to have the opportunity to present our research at the 11th International Conference of ICT for Sustainable Development. And I'll move on with my presentation. So our research title is an integrated AI-driven framework for early prediction and board-level surveillance of antimicrobial resistance. And our system is called Sentinel. We pursued this as our final year project at Sri Lanka Institute of Information Technology. There were four of us, myself, Jayat Disanayaka, Namod Jayala, Tenula Hettige, and Johan Nishankar. When we're trying to find out a research topic for our final year project, we noticed that in Sri Lankan hospitals and in most of the world, it takes about 2 to 4 days to get the antibiotic sensitivity report from the lab after a sample is collected from a patient. But doctors can't wait that long to start treatment, so they have to prescribe antibiotics empirically with their experience and patient general symptoms. Because of this, unnecessary antibiotic use keep rising, and over time, bacteria adapt and become resistant to even our most powerful antibiotics. This resistance cause more than 1 million plus deaths worldwide simply because there are no drugs that works. So patients are dying not from lack of treatment, but there are lack of options, and this is silent pandemic that most people don't even realize that happening. Uh, so with our guidance, with the guidance of our external supervisor, who is a microbiologist at Peradeniya Hospital, we selected 4 bacteria to focus on, and we were able to access the hospital's 2024 antibiotic sensitivity test results and patient demographics. Based on this data, we built our Sentinel system, which combines 4 functionalities: early prediction of methicillin-resistant staphylococcus, and board-level surveillance of Streptococcus and Enterococcus infections, bacterial infections, ESBL risk predictions, and non-fermenters resistance and trend monitoring. So for these 4 models, we prepared dataset using 2024 antibiotic sensitivity results and patient demographics. We obtained ethical clearance from the Peradeniya Hospital director. And for the splitting the data model around 12,000 plus samples for each module using 80 to 20 split from training and for testing. So here you can see our system overview diagram. On the left, we start with our data sources, hospital records, and microbiology data, and history results and patient demographics, and also the board informations of the patients. This data goes through our processing layer, where we clean it and handle missing values, engineer features, and prepare its weekly time series data for the AI models. In this middle, we have our main 4 functional modules: the antibiotic sensitivity identifier, predict resistance before ASC results come, and in using random forest and XGBoost, and the ward level outbreak identifier detects unusual infection patterns using isolation forest, and below that you can see the resistant evaluation predictor for forecast future resistant trends using LSTM, ARIMA, and Prophet models, and the non-fermenter surveillance module track the Pseudomonas and Acinetobacter using hybrid forecasting pipeline. So all 4 modules run through our central Sentinel AI intelligence engine, which combines machine learning, deep learning, and time series forecasting, along with the anomaly detection and prediction APIs. And everything is stored in the Sentinel database. This feed into our clinical decision support dashboard, which gives stewardship recommendation and outbreak alerts and risk scores of the antibiotics and their sensitivities, resistant trends for the future weeks, and this can used by microbiologists, physicians, and infection control team of the hospital and the hospital administration. Moving on to the our first function. Early prediction of methicillin-resistant staphylococcus. So in staphylococcus bacteria, come in 2 types, which is methicillin-resistant and methicillin-sensitive. Doctors need to know which one they're dealing with before choosing an antibiotic, but they can't because ASA results aren't available yet. So based on the past sample data and the antibiotic sensitivity patterns that are released, our model predicts the probability of MRSA that can be of this sample. This lets doctors start stronger targeted drugs sooner for resistant cases, while also reducing the risk of giving unnecessarily strong antibiotics to patients who don't need them, which helps prevent the further bacterial adaptation for stronger antibiotics. For this function, we use XGBoost and random forest as our prediction models, with key parameters including ward location, specimen types, and patient age groups, and early lab results such as gram stain and initial growth information of the sample. Moving on to our second function, which is ward level surveillance of Streptococcus and Enterococcus bacteria. These 2 bacteria commonly spread from patient to patient across the hospital wards. So in this model, we use patient demographics and AC results to detect outbreaks caused by these bacteria inside the wards. to do that, we split the data into weekly intervals and track where antibiotic sensitivity is changing at the ward level. And for that, we use LSTM-based time series forecasting along with the statistical deviation threshold for outbreak detection. When the model detects an outbreak, uh, whether it's already happening or likely to happen soon, it sends an alert to the infection control unit and the hospital administration. This helps the spread early by isolating infected patient in time. Moving on to our third function, um, which is ESBL risk prediction. So in the ESBL risk prediction, there are 6 beta-lactam generations, which separated to with separate split antibiotics, and we predict which generation a given sample containing E. coli or Classibella bacteria is likely to fall under. For this, we use multimodal XGBoost approach actually. So, and the system then suggest empiric antibiotic guidance based on the current sensitivity data in the hospital and the ward levels. This allows doctor to predict more accurate antibiotics by knowing which beta-lactam generation is likely to be effective for this sample for the patient. And moving on to our final function, non-fermenter surveillance. Uh, Non-fermenters, Pseudomonas, and Acidobacters uh, tend to spread through environmental factors rather than the person to person. In this model, we predict the coming week's antibiotic sensitivity for each ward uh, using a hybrid forecasting approach that combines time series modeling with statistical baseline estimation. We compare our predicted sensitivity against the real sensitivity data each week. If there's a deviation, it signals that spreading may be happening in the ward. This helps hospital administration identify affected wards early uh, and start sterilizing before the infection spread further. So overall, Sentinel successfully combines prediction surveillance and clinical decision support into one platform. This system achieved 89.3 accuracy for MRSA prediction and 85% outbreak detection rate across our surveillance module for the Streptococcus and Enterococcus, and 96.5 negative prediction value for ESBL risk prediction model, and it also maintained low forecasting errors of 3 to 5% for the resistant trend prediction of the non-fermenters. Uh, Most importantly, Sentinel helps clinicians make treatment decisions 48 to 72 hours earlier than they could with conventional AAC results, while promoting safe antibiotic use through explainable AI and stewardship recommendation. So this helps uh, to the society that spreading of bacterial infections, and also uh, reduce the use of very powerful antibiotics and stop the adaptation of the uh, bacteria to powerful antibiotics. So this is our presentation for our research paper. So thank you very much.
Okay, Jayanta, what are your concluding remarks? You didn't tell the concluding remarks.
Uh, so
You
our
stopped at result analysis, right?
yes, research
Okay,
analysis.
so
Yes.
please let me know your concluding remarks.
So our concluding remarks is, so for the I'll explain for each module. So for the MRSA, we identified that uh, there are uh, uh, to increase the prediction value. So there are parameters that we can use from the doctors itself, that whether they are experienced or not.
I am asking you the conclusion, the final one line conclusion you can tell.
Yeah, yes, I was included it in the, so So conclusion is from our system actually we were able to predict the this prediction before 48 to 72 hours, so that can uh, uh, stop spreading.
Okay, fine. Okay, wait, Jayanta.
Yeah,
Now I would like to ask some you technical questions. Let me know from where you got the data set.
we got from the Peradeniya hospital.
Whether it was free of cost given to you or freely available.
It was we don't have to pay them, but we have to get the all the required ethical clearance and the
Okay,
all the yes.
documentation from your institute. Got it. Now, let me know the parameters of the your data set. What are the parameters?
So the parameters are uh, specimen type, which is the which microbe, which bacteria is it, and there are
Mm-hmm.
two types of uh, bacterial types: gram sense, gram
Okay.
positive, and gram negative,
Okay.
and also the cell count
Sorry.
of these samples that they have found, and also the sample type, if it is a blood sample or a pus sample, which is called for the tissues and all,
Fine,
and
fine. Okay. Now, last question.
yeah.
It is very difficult to analyze some of the microorganism which are very near to each other with their features and specification. So, in that case, is there any ambiguity which you have observed while training your data set that this particular species is extremely difficult to analyze?
Actually, for that, uh, to answer to that is we have used four major bacteria that are available in the uh, Peradeniya Hospital dataset. So, uh, to identify those, that not the uh, content of our research, our content was to predict identified bacteria. So, the identification part is from the actually from the hospital. So,
Okay, fine, Jayanta. Okay, no problem.
thank
Fine,
you.
good one. No problem. We can move to the next one.
Thank you so much. Next, we have Prince Kumar with the paper title Automated Reproducible Cyber Hardening ARCH, a deterministic purple team orchestration framework for AI ready telemetry generation. Dear presenter, you may start presenting.
Yes, thank you. Uh, Good morning, everyone. Uh, uh, at Here at the 11th edition of ICT4SD, International ICT Summit in the beautiful city of Goa. Uh, my name is Prince Kumar, and today I am honored to present my research uh, titled ARC Automated Reproducible Cyber Hardening for a Deterministic Purple Team Orchestration Framework for AI-ready telemetry generation. This research focus on building a deterministic purple team orchestration framework designed specifically to generate AI-ready telemetry. This work was conducted at Defense Institute of Advanced Technology, Pune, under the esteemed guidance of Dr. C.R.S. Kumar and Dr. Anil Kumar Gupta. To understand the necessity of ARC, we must first look at the current threat landscapes. In recent years, we have witnessed devastating physical incidents, the SolarWinds supply chain compromise affecting over 18,000 organizations, the Colonial Pipeline 2021 ransomware attack that paralyzed the fuel distribution, and the Log4j vulnerability that allowed mass reconnaissance at an industrial scale. Why do we all these attacks have in common? That is adversary automation. Threat actors are leveraging AI, uh, LLM, and automated orchestration to weaponize zero-day exploits at unprecedented speeds. Yet we look at how we uh, defend and test our network. We are falling behind. Defense testing remains highly manual, fragmented, and non-reproducible. Red teams and blue teams operate in silos. This creates a severe data silo problem. Our SIEMs and IDS generates terabytes of unstructured logs, but because they lack the precise context of attack triggered them, they are largely unusable as a ground truth for training next generations of machine learning models. This brings us to the former problem statement of my research, that is, existing cyber range frameworks lacks a unified, reproducible, and deterministic orchestration mechanism that can tightly couple offensive actions with defensive telemetry. We need a system that generates structured AI-ready cyber data sets. To solve this, formulated my core research into four parts. That is, how can we automate the complete attack defense lifecycle in a unified pipeline? That is for we have a cross-platform gap where there are some Linux tools are not available on Windows for researchers. Uh, we can how can we mathematically correlate the attack defense actions with defense telemetry in real time, that is data silos for AI. So our proposed solution is ARC. Its core at its core, ARC is deterministic purple team orchestrator. Instead of letting attacks and defense run widely in the parallel, it strictly enforces a sequential knowledge-driven cyber experimental model. The cycle is rigid: initialize, attack, validate, defend, and finally knowledge commit. The framework is built on three key pillars: zero drift reproducibility, knowledge transition protocol, and Docker hybrid execution. Zero drift reproducibility ensures that by executing everything within Docker container on an isolated bridge network, we ensure that the environment is identical across every single run. For knowledge transition protocol, this token-based synchronization barrier that correlates every single defensive alert to its exact offensive trigger, successfully filtering out the 98% percent of ambient noise. And third, the Docker hybrid execution, which automatically routes execution across platforms, solving the age-old problem of running Linux native security tools from a Windows host. Let's look at the hood of the system architect. Arc operates on a modular four-layer design. At the top, we have a user interface layer featuring a rich CLI plus TUI where security analyst can configure backup plans using simple YAML files. Then we have layer 2 where orchestration layer. This is the brain of framework. It manages the session life cycle and runs the KTP synchronization engine. Next is the execution layer. This utilizes all our Docker hybrid engine on an isolated bridge network, specifically the host where we are, and the subnet separately containing all destructive payloads. Then we have data and telemetry layer. It here all logs are passed via SQL Alchemy and SQLite into structured relational knowledge records. This is the framework, architectural framework. As we can see, red team have, here I am saying, few tools like Nmap and Metasploit for simulating the real world scenario. Then we have blue team engine th- we have center orchestra that coordinates the red and blue operations, maintains the execution sequence, ensures the synchronization of attack defense cycle are according to the need of the user. And when these attacks happen in the defense, the knowledge are correlated as attack defense data and stored in a structured way in the database. We have an isolated Docker network secure sandbox environment for the impact. So we are using sequential system, not parallel, because in in traditional cyber ranges, red and blue teams operates concurrently. However, parallel executions creates a race condition between the attack execution and the log generation. Telemetry overlaps from concurrent sessions, making it nearly impossible to definitely say this specific alert was caused by this specific payload. This results data set is polluted and is unfit for machine learning training. However, in say, arc sequencer advantage solves this by forcing a strict chronological pipeline where the environment is reset to zero drift between every single cycle. We guarantee casual linkage combined with our KTP token synchronization, which generate high fidelity, pristine ground truth data that AI models desperately need. Here is exactly how the sequential methodology
Prince
operates.
Kumar, Prince Kumar,
Yes, sir.
make sure your camera is on during presentation and please do not read it. Please explain
Okay,
and make sure your camera is on.
okay. I am on the camera.
Fine. Be quick.
Okay, thank you. Here is the methodology. This is exactly what the sequential methodology operates. We have to initialize the Docker and we set the database. Every session goes through the different phases like initialize, attack, defend, and commit. Where first we initialize the Docker, then we execute execute the red team by giving the commands what we intend to do. Similarly, third we extract different telemetry from Suricata and Wazoo, where all the logs generated and the alerts that the system has are all captured by the Suricata and Wazoo, and that is stored here. Then we correlate those and we store it accordingly in the database, and that is the knowledge commit. We also for knowledge commit we have a heuristic attack validation algorithm where we parse the output and exit codes to mathematically verify that if an attack was successful or failed. We bother so we should gather the logs or not. Like as we I have mentioned in the knowledge commit algorithm, we generate the token hash of the attack config and timestamp. We inject payload, execute the attack, and blue team ba- API until time t they for an exact period of time they store the logs and they see the system, verify the system, and then after timestamp they extract the telemetry and with the valid timestamp of starting and ending, and then they store the commit in the commit knowledge record for tool integration. We have for red team engines we use the nmap metasquared hybrid, and we have performed DOS simulation. We have for blue team Suricata, Vazul, Log Mountain, and IP blocker, And for that team, we also have few more tools like Nikto, FTK. Like this knowledge record scheme per session, we have a pre-labor JSON record at execution time, when the execution occurred, session ID, which tool was used, which defense mechanism was used, timestamp, and and we so there's we are eliminating the manual feature extractions, directly feeding the agents the anomaly detected and how it was used. To evaluate the results, we conducted the control defense sessions. We have MTTR reduction of 81.7%. We conducted with the manual and the art, so we got that. Recon speed in Nmap was increased, and we filtered the noise, that is the false data were getting. We reduced by in as it was the system was isolated. As the system was isolated, we reduce it. Then we have Nmap and DOS reliability was 100%. These telemetry federation ablation study. So the brute force detection was 89%. Scan was that is we got a higher success rate with the scan, and for the multi-stage like Metasploit, where we have to execute deploy the payload, then execute it, then get the access. So that success rate was detection rate was 82%. Without Docker isolation, the reliability dropped by 45%, and environmental drift reintroduced. Despite the heavy orchestration, the peak system overload remained incredibly lightweight, under 42% of CPU usage and 2.6% of RAM usage.
Okay, Prince Kumar, please come to your conclusion part as you are
Okay, sir.
over
As
limiting
we
your time. So please be quick.
as To conclude this research, we have successfully designed and implemented arc transition cybersecurity experimentation from an ad hoc manual process into systematic, reproducible scientific discipline. We introduced knowledge transition protocol for automated red-blue correlation. We achieved 81.7% MTTR reduction, generated a structured knowledge record suitable for ML pipelines, and we demonstrated a zero-drift reproducibility via containerized microservices. Uh, I am pleased to say that we achieved what we intended to do. So, thank you.
Okay, fine. Prince, I have a few questions for you. Whether you have tested your system in real time with some kind of attacks?
Yes, sir.
Okay. And what about data set? From where did you got the data set?
Sir, data set was actually done using my own system with where I was working. There only to the data set we have to generate only to comparing also. So what we found from online few, and maximum of the data was generated by ourselves only, for because we didn't have, for purple teaming we didn't have that much data set available online also, so we have to mainly generate the data.
Okay, fine, fine, no problem. Okay.
Thank you.
Thank you so much
Yeah.
for that presentation.
Thank you.
Next, we have Manik Mandal with the paper title of Clinically Reliable Brain Tumor Detection from MRI Using Deep Learning with Calibration and Explainability. Dear presenter, you may start presenting.
Yes, ma'am. Good morning, respected session chair, conference organizer, reviewers, researchers, and all the participants present here. I hope my screen and voice are clearly
Yes,
visible
perfect.
and
You can
audible.
go.
Yes,
Yes,
sir.
yes.
Thank you for giving me this opportunity to present my research work at ICT4SD 2026. My name is Manik Mandol and I am a student researcher from Department of Computer Science and Engineering, Rajarambapur Institute of Technology, India. Today I am presenting my research paper titled Clinically Reliable Brain Tumor Detection from MRI Using Deep Learning with Calibration and Explainability. Before discussing the proposed framework, I would like to start with the motivation behind this research. In recent years, deep learning models have achieved excellent performance in medical image analysis. CNN-based model can detect tumors from MRI images with very high accuracy. In healthcare, achieving high accuracy alone is not sufficient. Model may give a wrong prediction with very high confidence, and such overconfidence errors can be risky in clinical environment. This research focus on developing a trust-aware medical AI framework by combining three implementation components: model calibration, uncertainty estimation, and explainability. Okay. Next, why this research matters. Brain tumor diagnosis requires accurate and reliable decision making. MRI is widely used for diagnosis, and deep learning models have achieved very high accuracy in tumor detection. However, in healthcare, high accuracy alone is not sufficient because a model can still make overconfident, wrong prediction. This research focuses on moving beyond accuracy and developing a trustworthy AI system by considering reliability, calibration, uncertainty, and explainability. I will discuss the main clinical challenges of existing AI system. Analyzing existing medical AI system, we identified four major challenges that limit their clinical reliability. First is overconfidence. Sometimes deep learning models generate wrong prediction with very high confidence. For example, a model may predict no tumor with 90%, 98% confidence. The tumor is actually present. This type of mistake can be risky in healthcare. And second is poor calibration. The confidence score produced by a model does not always represent the actual correctness of the prediction. Third is black box nature of deep learning models. They provide predictions but usually do not explain which MRI regions influenced the decision. And finally, uncertain decisions are not properly identified, so risky prediction may enter clinical workflows. To address this limitation, this research focuses on building a more trustworthy AI framework. Research motivation. The motivation of this research comes from the evaluation of the medical AI system. Initially, in the performance era, traditional machine learning approaches mainly depends on handcrafted features and focused on improving computational performance. This method has a limited learning capability, and later is accuracy error. CNN-based deep learning model achieve very high accuracy on benchmark dataset, but the main limitation was that reliability and trust were still ignored. Then can explainability error, where methods like GradCam improved transparency by showing important reasons influencing the decision. Explanation alone cannot guarantee a trustworthy prediction. Therefore, current is moving toward trustworthy AI era, where accuracy is combined with calibration, uncertainty estimation, and explainability for safer clinical decision support. So my research focuses on moving from accuracy-oriented AI trustworthy clinical AI. Based on this motivation, the major research gaps are identified as follows. Existing deep learning models such as CNN, ResNet, UNet, DeepMedic, and NNUNet have achieved very good performance in brain tumor analysis. Most of these approaches mainly focused on improving accuracy and performance metrics. But real clinical adoption, accuracy alone is not enough. Three important factors are required. The first is calibration, which ensures that model confidence matches the actual correctness of predictions. And second is uncertainty estimation, which helps identify unreliable or high risks is easier high risk cases where the model is unsure. And third is explainability, which help understand which MRI reasons influence the model decision. Research hypothesis. After identifying the research gap, we define the main research hypothesis of this work. The research question is: can we improve clinical reliability by jointly integration, calibration, uncertainty estimation, and explainability into a single framework? Our hypothesis is that these three components together can improve the trustworthy of medical AI system. Calibration improve confidence, reliability by reducing the mismatch between predicted confidence and actual correctness. Uncertainty estimation help detect risky or uncertain predictions where the model may require expert review. And next is last is explainability, provides transparency by showing which MRI regions influence the model decision.
Dear presenter, sorry to interrupt, but you have crossed the 9-minute mark. Kindly conclude your presentation soon.
Manik, be fast and convey your on slides and go ahead for the conclusion.
Okay. Sorry, sir.
Show the experimental work and directly go to the conclusion. Go fast.
Uh, these are the model contribution, trust your pipeline, temperature scaling, MC dropout.
Manik, go to the conclusion. Manik, go to the conclusion. So you don't have conclusion, direct future scope.
Uh, yes, sir.
Okay, fine. Now I would like to ask you few questions regarding the brain tumor data set. From where did you got the data set?
Mm, Kaggle, sir.
Kaggle, as usual. See, when it comes to research oriented project, then you need to have your own contribution towards data set as well. Why? Because all the data set are fully labeled, clean, crystal clean, available on Kaggle, and you guys need to just apply few algorithms and give up the result. That doesn't mean it is in research. So keeping that in mind, Manik, you need to also incorporate some amount of data from your side, or try to get an letter, official letter from the institute, and try to contact with the team of medical who are working on tumor data sets. If they are not able to give you for any type of privacy reasons, even you can keep such kind of gestures in your presentation that I have tried for the same. And hopefully next time make sure that your presentation should be within the time limit.
Okay, sir.
Fine.
But
We
these
can,
are
yeah.
these are for future work. I already put this. Uh, we should. What are you told this for about this? This is the for future work.
Yeah, right now, whatever work you have done, you should be enabled that work with real-time data set as well. Okay,
Yes, sir.
fine, no issues. We can go with the next one.
Thank you so much.
Welcome.
Can you stop presenting? Thank you. Up next is Sarthak Babasaheb Zurale with the paper title Cloud Shield CAONT Efficient Data Dynamics and Ownership Management in Secure Deduplication Cloud Environments. Dear presenter, you may start presenting.
So, cloud computing has become one of the most widely used platforms for storing and sharing data because it provides scalability, flexibility, and cost effective storage. However, as the number of clouds users continues to grow, the amount of duplicate data stored on cloud servers also increases, resulting in unnecessary storage consumption and higher operational costs. To address this issue, cloud providers use the techniques called data duplication, which stores only a single copy of identical data while allowing multiple users to access, access it. Although this significantly improves storage efficiency, it also creates challenges related to data confidentiality, ownership management, and integrity verification, especially in multi-user cloud environments. Overcome these challenges, we propose Cloud Shield CONT, a secure cloud storage framework that integrates convergent all or nothing transform or CONT with block level deduplication, dynamic ownership management, and third party auditor based public auditing. The proposed framework enables secure data storage, supports dynamic operations such as insertion, modification, and deletion, and also ownership transfer while reducing computational overhead and ensuring data confidentiality, integrity, and efficient storage utilization. So these are our problem statement. Although many secure cloud duplication schemes have been proposed, they are still unable to efficiently support data dynamics, dynamic ownership management, and public integrity audits. Simultaneously, in most existing approaches, whenever data is updated or ownership changes, the entire ciphertext has to be re-encrypted and authenticators need to be recomputed. This results in high computational overhead, increased processing time, and reduced scalability in multi-user cloud systems. So, uh, talking about our objectives to overcome these to address these uh, objectives, we design a secure deduplicated cloud storage framework by integrating stack and also CONT algorithm. So this is our literature review where we have managed to go through multiple papers where we have studied the already existing systems, and through these existing methodologies we have developed our methodology. So the process begins when a user uploads a file to a cloud. The file is first divided into blocks, and a SHA-256 hash is generated for each block to identify duplicate data. If a block is already existing on our system, the system reuses the existing ciphertext and updates its owners. Otherwise, the unique block is encrypted using the convergent all or nothing transform or CONT before being uploaded to cloud storage. Next, the framework manages file ownership using the index switch set mechanism, which efficiently supports insertion, modification, deletion, and ownership transfer. Without requiring complete authenticatory computation, when another user uploads an existing file, a proof of ownership protocol verifies that the user legitimacy possesses the data before granting access. Finally, a third party auditor performs public auditing to verify data integrity without accessing the plain text, ensuring secure, reliable, and efficient cloud storage for multiple users. So, moving on to our implementation details. The system was developed using the MERN stack, where React.js provides the user interface, Node.js and Express.js handles the backend, and MongoDB is used to store metadata, such as file hashes, ownership record, and index set. For secure reduplication, uploaded files are divided into blocks, hashed using SHA-256, and encrypted using the CONT mechanism with AES-256. Duplicate blocks are identified through hash comparisons, ensuring that the only one encrypted copy of identical data is stored. The encrypted files are then stored securely in AWS S3, while MongoDB maintains the associated metadata, support efficient ownership management, and dynamic updates. To ensure security, the system implements a proof of ownership protocol to verify legitimate users before granting access to duplicate files. So, moving on to our results. So, what we have achieved is we have divided into two blocks. First graph represents computational overhead, and second represents storage optimization. So, As shown in the graph, the computational time of the traditional approach increases rapidly as the number of updates grows, rising from approximately 520 milliseconds for the first update to around 2480 milliseconds by the fourth update. This is because the traditional scheme require complete ciphertext re-encryption and authenticator recomputation after every update. In contrast, our proposed framework shows only a gradual increase in computational time from about 140 milliseconds to 640 milliseconds. This improvement is achieved through the index switch set mechanism, which updates only the affected blocks instead of recomputing the entire system. As a result, the proposed system reduces computational overhead by approximately 73 to 75%, making it more efficient and scalable. Whereas talking about storage optimization, the graph compares the storage consumption of the traditional file level deduplication approach with our proposed block level deduplication and schema across four different data sets. As we can observe, the proposed framework consistently requires less storage space and then the traditional approach for every data set. This improvement is achieved because our framework performs block level deduplication where only unique encrypted blocks are stored. So moving on to our conclusion, CloudSwitch CONT provides a secure and efficient cloud storage framework by integrating CONT-based encryption, block level deduplication, dynamic ownership management, and public auditing into a single solution. The proposed indexed switch set mechanism significantly reduces computational overhead during dynamic data updates while maintaining data confidentiality, also the integrity and efficient storage management. Our experimental results demonstrate that the framework achieves substantial improvements in computational time and storage utilization, making it scalable and reliable uh, solution for the secure multi-user cloud environment. So future scope for our research is uh, that we can integrate this solution blockchain based auditing logic to provide tamper resistant and transparent integrity verification. Additionally, attribute based encryption along with cross cloud deduplication can be incorporated to enable fine gained access control and secure data storage multiple cloud providers. So thank you. Thank you for your attention. I would be happy to answer any questions.
Okay, Sarthak, let me know. You have used the security for the cloud. Right now, there are variety of security measures that can be applied with cloud infrastructure. How you are going to compare your system with the existing one?
So in existing system, there exists a file level deduplication. So entire file is again deduplicated if there is only little change. But in our system, we introduced block level deduplication. So we created blocks of the file, and only the changed block is re-encrypted again.
Okay. What about the time that takes for encryption?
So as you can see, the encryption time we have shown as a computational overhead. So the computational, so first it is required 520 milliseconds, but we have reduced it to 140 milliseconds.
Imagine I want to encrypt the data, video data, which is nearly about 30 to 40 GB at a time. Then what would be the complexity of your system?
So uh, we can say that if there is a requirement of 1000 milliseconds in the existing system, then we have reduced it to 70%. So we would require around 200 milliseconds.
Fine, no issues. Okay, good one. We can go with the next.
Thank you, ma'am.
Thank you so much.
Thank you.
Next, we have Vidya Raj with the paper title deep learning based automatic attendance system using real time face recognition with CNN and FaceNet. Dear presenter, you may start presenting.
Hello. Hello, ma'am. Am I audible to you? Hello. Ma'am, could you please give me a 5 minutes? If you can, next one. I have some network issue, so it is couldn't possible right now. Just 5 minutes. Next presentation. Please request. Hello.
Yes, okay, ma'am. We are following a schedule, so we can take your presentation at the last.
Ma'am,
Okay.
can I share my presentation now?
Ma'am, we have to follow our schedule. We will let you know when you are presenting your presentation.
Okay, ma'am. Thank you.
Okay, next we have Kavita BC with the paper title Face Recognition Based Smart Attendance Management System. Dear presenter, you may start presenting.
Hello. Hello.
Present.
Am I audible?
Yes, sir.
Uh, I'm presenting the screen. Am I visible?
Yes, sir.
Okay. Morning, respected distinguished guests, professors, and fellow participants. I am Tarak Sriram from Arpadai Video Institute of Technology. It's me a great pleasure to face smart attendance in 11th International Conference of Communication Technologies.
Sir, sorry to interrupt, but your voice is breaking.
Oh, is it okay now?
It's still breaking, sir.
Am I audible now?
Yes, sir.
Yeah. In this presentation, I will briefly discuss motivation behind the work, the methodology followed, and the future scope. The management, the attendance management is an important activity in the educational institutes and organizations. Traditionally, attendance is recorded manually using registers or conventional methods. However, these methods require significant time, are prone to human errors, proxy attendance, and lack of accuracy and efficiency. So it's a kind of outdated system. So as we are moving ahead with the technology, we are
introducing AI, internet, and many more things. So how to improve this also? The main concept of the research is that we have to automate student attendance using face technology, using HOG, DLIB, and linear SVM. Record attendance automatically with timestamp, improve accuracy, reduce effort, efficient attendance management. The With the advancement of artificial intelligence and computer vision, technologies face recognition provides an efficient solution for automated identification and verification of individuals. Our main objectives of our research is to develop a smart attendance management system that can automatically recognize faces, mark attendance, and maintain records digital.
Dear presenter, you are not audible.
Okay, am I audible now?
Sir, your voice is breaking.
Now,
It's better now.
okay. Can I continue?
Yes, sir.
Yeah, see, we are existing system. Our this is to oxidate. It does uh,
Taraka Sriram, your voice is breaking too much.
so
Wait. Taraka Sriram, your voice is breaking too much. You go to the concluding remarks. Let me see the conclusion.
yeah, is to fully in real-time recognition, automated marking system, reduce manual efforts, etc. We have used etc. and face recognition attendance making system. We can easily note the attendance and share the real-time attendance to the students as well as the faculty at the same time, and it uses less time and it can be done easily. It has many advantages like eliminating proxy attendances, accurate record keepings, and it will not divert the class from the topics. That's the point in this.
Okay, fine. Tarak Sriram, I have a few questions for you. First is how a normal student is going to give his attendance?
When he
Yes,
stands the
Taraka
device,
Sriram.
pick
Yeah.
off him and it will compare it to the
I guess he is not audible. We can go with the next participant.
Okay. Thank you. Next, we have Bhumi Singh with the paper title Fair IM GNN, a unified framework for fairness and diverse influence maximization via adversarial GNNs and hypergraph modeling. Dear presenter, you may start presenting.
Sure, thank you. Am I audible?
Yes, ma'am.
All right. I hope my screen is visible also.
Yes, ma'am.
Okay, so good morning everyone over here. Thank you for having me here. Today I'm here to present my paper, Fair IM GNN, a unified framework for fair and diverse influence maximization via adversarial and hypergraph modeling. My co-authors for this particular research paper are Aryan Chaudhary, Saurav Kumar, and Dr. Sanjay Kumar. So, moving ahead, talking about the problem statement that we aim to tackle with this particular research. Yeah. So, talking about a classical influence maximization problem, when we talk about influence maximization problem, it is a typical graph problem, which is an NP-hard problem, which is solved using certain greedy or submodular approximations. But tackling the influence maximization problem, we leave back a very important aspect, that is maintaining fairness. Fairness is basically representing all the demographic groups into a final representation when we have a final seat selection for any particular node embedding. So the traditional influence maximization models, as shown on the screen, they have this particular problem where they leave back the minority or the peripheral groups, and these are excluded from the final seat selections. What we aim at is a fair and diverse influence maximization system with an equally good spread. So the research gaps that we identified uh, during the initial phase were that in most of the existing models, we have one a single signal fairness. That is, we just have a gradient reversal layer that is an encoder and decoder system, which tackles the non-linear dependencies of the node embeddings and the sensitive attributes of the particular data, but it does not tackle the linear dependencies within these two aspects. Second is that most of the current models, they are based on typical GNNs, and GNNs, as you all might be aware, they just have a single node edge pair, so they cannot capture multiple nodes over a single edge. Therefore, they would not be able to capture the entire complexity of the data set available. Third, the current data that is available to us or to anyone has a lot of noise to it, or this particular data might have a lot of errors or missing edges, missing nodes, etc. What ideally we should have is having the same amount of fairness influence spread over such augmented data set too, but the current models do not tackle this explicitly. Fourth, fourth is that fairness and diversity are not two things that are equivalent to each other. These are two separate things. We can have a really fair system and not be able to reach to all the communities present in the data set, and thus our aim would be sidelined. So this is what our particular model looks like. It works in two particular stages. The first stage is we focus on fair representation learning, and in the second stage, we have a strategic seat selection so that we do not miss out on particular demographic groups. So in particular, when we talk about adding fairness to our architecture, we firstly put our graphs and its sensitive attributes inside an encoder. The encoder is the graph attention network uh, inculcated within hypergraph encoder. This particular data goes through a dual adversarial fairness check, which uses gradient reversal layers, and a covariance constant, which is a mathematical statistical constant added to tackle and improve fairness. Lastly, we ensure a robustness by having multiple augmented data sets too. These particular fair embeddings are then passed on to a second stage in which we are selecting particular seed nodes. These seed nodes, we are combining the fair k-means clustering algorithm so that the fairness is maintained across each cluster. And in order to select the seeds from these particular clusters, we're using MMR selection, that is maximal marginal relevance based selection. So, talking about all these things in a little bit detail, as I mentioned, we use a dual adversarial fairness. The first is the gradient reversal layer, which is an encoded decoded system in which we tackle the non-linear dependencies between the node embeddings and the sensitive attributes. Sensitive attributes could be anything related to the data, suppose the age or the gender or any race or locality of a person by which he or she may be discriminated against the entire community. So basically, we tackle and remove the relations between these two particular aspects so that the model does not discriminate between two particular socioeconomic groups. The second is a covariance penalty, which is a statistical term which is added to the loss function, and it just is a kind of a backup fairness which removes the linear dependencies between the sensitive attributes and the node embeddings. Talking about hypergraph modeling, hyper edges are basically uh, edges containing multiple nodes, and basically these represents all sorts of complex interconnections between various nodes in, inside our entire graph network system. Coming to graph contrastive learning, what we tackle here is basically we want a robust system. Like I mentioned earlier, we can have multiple graphs with missing nodes, missing edges, or some other data which is missing from the data set. So we really need to tackle that using by training our model so that it works on similar graph structures even if some amount of data is missing from it. Now, once fairness has been tackled or talked about, we will have to select particular seed nodes, and then for basically spreading entire data or instructions. So for that, we have a pair k-means clustering. So in this, we form clusters of size k in such a way that basically in such a way that the entire in whatever proportion the communities or social groups are present in the entire data set, they are mirrored into each one of our clusters. Now maximal marginal relevance is basically a seed selection criteria where we select when we are supposed to select one particular seed from these clusters that we formed by a fair k-means clustering. So that we just need to ensure that we do not keep on selecting the same kind of seed nodes from each of these clusters, because then our aim would be hampered. So we have a mathematical constraint, and therefore we basically penalize in case we select two similar seed nodes from two different clusters. Now, talking about the data set and the experimental setup on which we worked upon, we used a real world social network data set, the Facebook data set to be very precise. The propagation model that we used in order to calculate our spread is the independent cascade model, and we averaged it over 2000 Monte Carlo simulation runs. We increase the size of our seed sets from k is equal to 10 to k is equal to 50 and produce data on each one of these. The metrics that we use to find our results are the fairness score, the community coverage, and total influence spread. Fairness score is basically a measure of how fair, that is, how many of these demographic groups are equally represented in proportion to their actual weight in the entire data set. Community coverage is whether we covering all the available or present communities of a data set, and total influence spread is to how many seed nodes or nodes we are particularly able to reach from our particular model. The baselines which we use for comparison in the initial phases of the research are an adversarial or a GRL only embedding model and a greedy influence maximization model, which does not consider fairness into its equation. So these are the results that we got. The fairness score that we could manage at k is equal to 50. The maximum fairness score that we got was 0.89. With a community coverage of 0.9, which basically means that we were able to reach out to 90% of the total socioeconomic groups. We still left out around 10%. Uh, uh, and the number of nodes activated out of the 4,000 nodes present in our data set is 2870. This is basically a measure of the influence over the entire data set that we had. Below shown are the graphs which basically show that our fairness score, community coverage, and influence spread, each of these increase as we increase the size of our seed set. Now, this is just a comparison analysis from the baseline models, and it is basically a comparison. Overall, on the right graph, if you see, it is an overall fairness versus influence trade-off. Both the baseline model and our model are working in a similar fashion. The only good thing is that our particular model has a higher influence spread and a lesser fairness gap, which we initially aimed at. Now, concluding this particular research, I would like to say that we basically presently we focus upon increasing our influence over as many seed nodes as possible, and we in this process leave behind the marginalized groups or less socioeconomically available groups in the data set, and we need to tackle this particular problem with the advancing of AI with over these ages, and these are the multiple algorithms combined together to form one particular model so that we are able to tackle this problem all at once. The future work for this particular experiment is having a more dynamic or a real-time graphs and involving them into our architecture and scaling this into a fairness-aware recommendation system. Thank you. That is it from my end. I'm open to questions.
Thank you so much. Do we have any questions?
Sorry, sir, but you're not audible. If you could repeat.
Yes, whether I'm not. Yes, I guess I am now audible.
Yeah, yes, sir, you're not audible.
Yeah, let me know the real-time applications of your system where we can apply this fairness.
Yes, sir. So basically, I will let you know one particular drawback on basis of which we started this particular researches. Initially, when Amazon started off with an AI-based resume screening system for its applicants, particularly for the SD role, there were a lot of drawbacks to the particular system because they were sidelining resumes based on the minority groups, such as a female applicant or a fresher with very less number of years. So that is a kind of a situation in which improvement, the AI-based resume screening improvement is required over where we kind of ignore the demographically less available groups in that particular situation. That is a real world example that I can give you.
Okay, fine. Okay, no issues. Perfect one. We can go with the next.
All right, so thank you so much, everyone.
Thank you so much.
Yeah, just a second.
Next is Anuprita Mahapankar with the paper title Minute-Wise Asynchronous Meeting Intelligence with Phonetic Participant Matching and Workflow Integration. Dear presenter, you may start presenting.
Am I audible?
Yes, ma'am.
Okay. Is my screen visible?
Yes, ma'am.
Hi, good morning. My name is Anupreeta Mapankar, and today we are presenting our research paper Minute-Wise Asynchronous Meeting, Intelligence with Phonetic Participant Matching and Workflow Integration. And my co-authors are Riya Chaudhary, Sneha Patra, Isha Chavan, and my mentors are Shalu Chopra ma'am and Anushri ma'am. Moving on. Meetings are essential part of each and every organization, but documenting them is both time-consuming and error-prone. Existing meeting assistants provide you with live meeting support, but organizations still rely on the offline meeting. Another major issue is the participant identification, which arises due to the ASR, that is automatic speech recognition, which produces inconsistent meeting transcription and summarization. And finally, there is no workflow to automate this entire process. So as you can see in this diagram, once the meeting is conducted, a person is allotted to write down the minutes of meet, who may miss few tasks, which may lead to delayed follow-up. Research contributions. So MinuteWise contributes in four major ways. First, we have is the end-to-end meeting intelligence pipeline, which automates the transcription, summarization, and action item extraction. Second, we have is the multidimensional phonetic participant matching algorithm, which helps us to correctly identify the participant name using multiple similarity measures instead of relying on a single measure. Third, we have is the hybrid AI action item extraction, for which we use Gemini and rule base for the fallback. And finally, workflow automation. So once the action item are extracted, we integrate it with the workflow tools like Jira and email. Moving on, so this is the overall architecture where we first record the meet using our mobile app, or the existing meeting recordings are uploaded via the web. Next, the audio is processed to produce the transcript using the Whisper AI. Once we get the transcript, we correct the participant's name using the phonetic participant matching algorithm, which then produces two modules, summary and action items. The extracted action items are then integrated with workflow tools like Jira and email, and the entire thing is stored in the Supabase database. So today we are going to have a look at participant matching algorithm and the action item extraction. Moving on. So participant matching algorithm. One of the challenge in ASR, that is automatic speech recognition, is the correct participant name identification. So for example, the participant name Sneha, can be incorrectly transcribed to Neha. Exact matching or fuzzy matching is insufficient because phonetically similar names are still different. So to handle this, we use a multidimensional similarity, which uses the 5 similarity measures. So let's see them one by one. First, we have is the sequence similarity, for which we are using the Livingston's formula, which suggests how many insertion, deletion, or substitution is required. So in Neha, only S needs to be added to make it Sneha. So according to the Livingston formula, we have 1 minus 1 upon 5, which is 0.8 as the similarity score. Next, we have is the first letter match. So over here, the candidate name Neha has the first letter N, and Sneha has first letter S, which is not equal. So similarity score is 0. Third, we have is the length similarity. So Neha has 4 letters, Sneha has 5 letters. So similarity score goes as 4 upon 5, which is 0.8. Fourth, we have is the consonant match. So over here, we check for the consonants. So Neha has NH and Sneha has SNH. So again, applying the Livingston formula, we get 1 minus 1 upon 3, which is 0.67. And over here, 0.2 is added as the bonus because it is containing the same sequence NH. Similar to consonant, now we check for vowels. So over here, Neha has EA and Sneha also has the vowels as EA. So the similarity score is 1. Also, we have assigned weights to each one of them. So multiplying the weights by similarity score, we get 0.3 into 0.8, 0.15 into 0, plus 0.15 into 0.8, plus 0.25 into 0.87, plus 0.15 into 1, which gives us the score as 0.72. Also, we have kept the threshold as 0.6. So any name which exceeds the threshold of 0.6 is considered as the best match. So over here, the Neha is replaced by Sneha. Moving on. Now action item extraction. Once we get the corrected transcript by replacing the participant name, now we extract the action items. So there is a pattern in each of the transcript. For example, Sneha will be working on task A, or Ria is assigned task B. So Gemini helps us to extract the name along with the task. Once the task is extracted, now we categorize the task into high priority, medium priority, and low priority. So for example, end of day EOD is assigned as high priority, and this week is assigned as low priority. Based on that, we give the confidence score. And deduplication. In deduplication, we remove the similar tasks which are repeated again and again in the meet. And the final output which we get is the action items. Experimental results. So we have achieved a 4.2% of word error rate, which indicates a high transcription quality. And also we have achieved a 91.7% of participant name accuracy, which was initially 71.4%, which on implementing our phonetic multidimensional similarity algorithm, we have given it a boost of 20.3%. So moving on, comparison with the existing systems. So our system, or our software MinuteWise, has offline meeting processing, and along with the phonetic participant matching algorithm, along with action item extraction, and integrating it with the workflow tools like Jira and email. Limitations and future work. So limitations are, first of all, we are not having any speaker direction as of now, like who said what. And our meetings are primarily evaluated in English, and that too on a limited data set. And our software is designed for asynchronous meetings, that is the offline meetings. So our future work is to improvise these by working on real-time meetings like Zoom or Google Meet. Second is multilingual support apart from English, supporting multiple languages. Third, to work on a larger data set. And fourth is speaker direction, that is who said what. To finally conclude with, our MinuteWise automates the transcript, summarization, and action item extraction, introducing a multidimensional phonetic participant matching algorithm to correctly identify the participant name, integrating the workflow tools like Jira and email, and achieving a high transcription quality of 4.2% of word error rate. So thank you. I would love to answer any questions.
Okay, Anupika, it is quite innovative concept. May I know how you are going to create whatever we are going to speak into a transcript? What is the logic?
I'm sorry. Whatever. Like, can you repeat?
Yeah, I will repeat. Imagine right now I provide you the downloaded version of this particular meeting. So how you are going to extract the transcript?
So yeah. So we will get the transcript, like the recording. So may I present the screen again? Okay. Over here we have the, okay. So now I have the web upload. So I have the meeting recording. I will upload it into the web, and then it will undergo the processing pipeline. So I will get the audio, I will process it, and we are using for transcription Whisper AI. So what will happen is the audio is processed. First of all, we are also before proceeding it to like Whisper AI, we are also removing the algorithm, like like whatever the filler words are, and then we are processing it to Whisper AI. So Whisper AI helps us to transcript it, like whatever the audio we are getting, we are transcripting it. And then once we get the transcript, now suppose I am saying like this task is being allotted to this. So our participant matching algorithm helps us to, like, from the participant database, whatever the database we are having, over here. So as you can see, so Sneha, Ria, these are the participant database. So we extract the participant data from that, and compare the transcript and correct the participants, which helps us to extract the action
Okay,
items
okay,
based
okay,
on the
okay,
Gemini.
okay, fine.
And
Okay,
then,
okay, fine. Okay, fine. We got it. Next and last question is, imagine
hmm,
somebody has joined with somebody else account. For example, if I am not having a proper network, even though the
uh,
name is shown on my behalf, but somebody else is speaking. In that case, how you are going to tackle?
okay. So, first of all, we are not having any speaker direction as of now. That is who said what. So, we are just having the transcript. So, once we get the
Fine,
transcript, and according to the transcript, then we have the names and all. So, Gemini helps to extract the according to the name. So,
fine,
all
fine.
is,
Okay, 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 fine, okay, fine. Good one.
so should I stop presenting? Like, is
Yeah,
it
yeah,
done?
yeah, yeah, yeah. Yes, it
Thank you.
is done.
Thank you
It is
so
done.
much.
Thank you so much for the presentation. Next is Vaishnav Vankar with the paper title PRISM Proactive Red Blue Intelligent Security Model Using AI Agents for Autonomous Cybersecurity Testing. Dear presenter, you may start presenting.
Thank you, ma'am. Ma'am, I'm audible.
Yes, sir.
Okay, ma'am. Can you please confirm if my screen is visible?
Yes, sir, it's visible.
So, good morning, respected session chair and my respected fellow researchers. My name is Vaishnav Vankar, and today I'm going to present my work, PRISM, Proactive Red Blue Intelligent Security Model Using AI Agents for Autonomous Cybersecurity Testing, carried out at DIIT Pune under the guidance of Dr. CRS Kumar sir and Dr. Anil Kumar Gupta sir. Following are the contents that I will be covering in brief in the following slides. Before we move to PRISM, I want to introduce you to few terms. Red team, it is basically a team, kind of ethical hackers who do the who do the work of finding the vulnerabilities. Then there is a blue team, which of course specializes in detecting and responding to attacks. Then there is a purple team who coordinates between these two teams to uh, improve the both attack simulation and defense. And the AI agent, which is now very popular in the AI field, which is actually an AI program that is capable of reasoning, planning, and acting to achieve a specific goal. An orchestrator is actually a controller that guides these AI agents, multiple AI agents, to achieve a common goal. So, introduction. So, let's consider a medium-sized organization. It conducts the security testing of the organization once in a month, and during this period, new vulnerabilities arise, new services are deployed, and attackers also evolve. So, this leads to a very vast attack surface. Um, According to the IBM's Data Breach Report of 2025, it takes around 241 days for an organization on an average to identify the and contain the breach. So we saw that the LLMs are now capable of reasoning, planning, and acting on their own. So we thought of why not to uh, research and use them to achieve autonomous cybersecurity testing. So this is the literature review carried out on the existing systems like Pentest GPT, Auto Attacker, Checkmate, Defender, Bench, and Saga. The problem with these existing frameworks was that they were focusing on one aspect, like only on offensive testing or defensive testing, or just coordinating the AI agents. There was uh, there was no system existing which actually coordinated the offensive and defensive exercises, which basically means the purple teaming. So these research gaps. So after literature, we found this research gap, which was the absence of integrated purple teaming automation, and there was very limited multi-agent use in the cybersecurity field. Actually, also in the collaboration, many were as a standalone, or there were no use of agents, and then there was a lack of adaptive mutation mechanisms, like only the behavior of the attackers were detected by uh, uh, behavior detected by the defense systems and were improved, but there was no collaboration between them, and provider agnostic, means that many AI systems relied on one single LLM, which which provides bias, which we'll see in coming slides. So this led to a research question, which was that how can LLMs be leveraged with a multi-agent architecture to autonomously orchestrate collaborative purple team exercises, which will actually improve the attack and defense with a continuous feedback loop. And the objectives we set were that to develop multi-agent architecture and then a structured orchestration pipeline, which was mapped to a method attack framework widely used in the cybersecurity industry, and then to develop adaptive attack mutation. Then how can we integrate the existing security tool chains so that they can be used automatically, and then how to evaluate efficiency, and how to develop the how to present the output to the users. So this is the system design and architecture of our work. So basically, user designs the testing objectives. The coordinator agent catches them and maps it to the method attack framework, and then it distributes that strategy to the red agent. The red agent in an isolated environment, which is Docker Power environment, carries out that work through reasoning, planning, and acting. It fetches the tools and all. And similarly, the blue agent from that isolated container extract the telemetry logs, alerts, and it performs its defensive analysis. And through where the results are provided to the coordinator agent. This is the loop. Now, why multi-agent? Why can't single agent do this? Multi-agent gives us the ability to use different models for different works. If we use a single LLM agent for one single task, then it can execute the attack and it can evaluate the attack on itself. So it may present the self bias. And also we know that there is a context window for every large language model. So if the context window, if gets for, as we can see, the testing cybersecurity testing phase is a very lengthy, so the context may get forgotten. So this why if the separate task is given to separate agents, they carry out it very efficiently. So this is basically the roles of the each agents. Basically there are three agents. So red agents, it will attack planning using the method attack knowledge base. Then it will based on that, it will select the tools from the isolated environment. It will generate commands, attack, mutate when detected, and basically it's sub-role cells recognition, scanning, and analyzation. The blue agent, it injects the telemetry from the isolated environment. It through detection rules, it detects the attack, and then its sub-roles are harden, monitor, and remit. And basically coordinator agent is actually decides which task to disperse to which agent. So this is the orchestration loop. Basically we will understand with the right side sequential diagram. The coordinator, it phase plans the phase and selects the TTPs from the method attack. It provides to red agent executes the command using the tool runner in the isolated environment. The tool output is again analyzed and the attack result is provided to the coordinator. The coordinator then provides the analysis logs to the blue agent and the detection report is provided. If the attack is detected, then it advises the red agent to try different strategies and mutate. And if the attack is missed, then it trains the blue agent to try different uh, detection rules to capture the attack. And similarly, the next phase continues. We can see that we have n iterations on the left. So we have put so that we do not go out of the token consumption window. So this is a dynamic threat score. It is developed on the general principle of calculating the threat in the cybersecurity field. It is basically the sum of the impact score, exploitation probability, and it is the detection status, which is the factor introduced by us. So if we say that if the attack is detected, it means the d of t becomes 1 and the it contributes nothing to the dynamic threat score. But if the attack is not detected, it is 0 and it contributes the dynamic threat score, and we need to focus on that attack as a priority. So this is a penetration testing execution standard. We have followed it only, which is reconnaissance, enumeration, control exploitation, post exploitation, and blue team review. It is a standard penetration testing standard we have incorporated in our one of the workflows in our architecture. So this is the operational first. We have discussed everything before. The analyst configures LLM, sets target, initiates assessment, follows the 5S flywheel discussed in the previous slide, and a generation of report. We have implemented some safety and security features that as the command is initiated, it first goes through the validation. It blocks destructive patterns like RM, RF, and we also run in the safe mode, like it should not go out of the scope, and also the all the audit is mentioned in the logging. Also, timeout information of 300 seconds is provided, that if it unable to run in the 300 seconds, it is discarded. So we have used a Python ecosystem as our tech stack, basically using Python as our main language, and then security tools, installing the Kali Linux in the isolated Docker environment. For testing, we have used Ubuntu server, basically a
Okay,
Linux virtual machine.
Vaishnav, go to the conclusion part.
Yes. So this is the conclusion.
Okay.
Basically,
Yeah, fine. So you have used LLMs
yes,
for pipelining.
yes, sir.
Okay.
Basically, we
Have
have
you
generated.
gone with have you gone with the real-time attacks?
Actually, not real-time attacks, but we have done it only on the virtual environment.
Okay. So for virtual environment, the intensity of attack, how you're going to manage it? How you're going to do that? Or you have just worked with the data sets?
No, sir. Actually, through an API, we have used the two already available data set, we can call, like Meter Attack Database and National Vulnerability Data Set.
Mm-hmm.
So we through
Okay.
API call, we are calling. What happens is that as LLM, the user is able to provide instruction as a prompt or as a keyword base. So on that base, using the regex, it uh, finds the key, like key attack patterns like excesses or IDOR vulnerabilities, and according to that, it plans the whole execution phase.
Fine. Okay, no problem. Good one. Very innovative one. Like the way you presented as well. It was nice one. Yeah.
Thank you, sir.
So we can go for the last presentation of the day.
Thank you so much.
Thank you.
Now we have Shavani Rasam with a paper titled Screening of Neurological Disorders Using Behavioral AI. Dear
Emma,
presenter, you may start presenting.
thank you so much for the introduction, ma'am. Am I audible to you?
Yes, ma'am.
I'll share my screen just a minute. Is my screen visible?
Yes, ma'am.
Okay. So, a very warm good morning to all the respected members present in the meet. My name is Shravani Rasam. Today, me and my teammates are delighted to share you our topic of research, that is screening of neurological disorder using behavioral AI. Now, our entire work revolves around a very specific question, that is, can we identify the early signs of dementia in a patient just by looking at how the way they speak or they move, instead of relying on some expensive MRI scans or some invasive complex procedures? This is what our work does. So, let me guide you through how we designed an AI powered low cost screening tool. Okay. So, dementia is a type of neurological disorder wherein person tend to lose their cognitive and motor skills. It extensively affects their daily life. So, it is a very serious problem. Unfortunately, the detection of dementia is done at a very later stage wherein there is a significant decline in their cognitive behavior. However, research says that there is a subtle and gradual decrease in their ability to talk, to walk, the way they speak. So this can be captured and analyzed. This is exactly what the exactly drawbacks which caught our attention for our research work. So we tried to focus on the speech and mobility part of the dementia patient, which led us to the screening neurological disorders. So before going into the deep dive of our project, let us have an actual gist of what exactly the problem is. Around 55 million plus of people face this neurological disorder problem all around the globe. The main issues they face is that not just the treatment, it is that the treatment is very complex, it is expensive, as well as it has a limited access and it is not available in the rural areas. The research gap and the literature review shows us two major gaps. That is, first one, the speech trained AI models are extensively trained on English dataset. However, in countries like India, wherein multilinguality exists in every corner of our streets, this model failed to do the justice. The second drawback was that the speech and mobility are studied as two independent topics. However, we decided why not combine both of them. So we built a co-equal independently validated pipelines, that is speech and mobility, as well as we developed a native support for languages like Hindi and Marathi apart from English as well. So this is a proposed system. Our main aim was to automate few of the clinical tests which are performed by clinicians and doctors during the initial screening of dementia detection. So we have two pipelines, that is speech and sample pipeline and TUG mobility pipeline. I'll explain in depth each of the pipeline. So this is a basic flow. When the speech pipeline, the person has to record an audio and it is passed through pre-processing and further models. And in TUG pipeline, the person has to record a video and it is further followed by our pipeline. We'll see everything in detail. So this is speech pipeline. So we try to automate this cookie theft test. So in this particular test, the dementia patient or any person is given this picture and they're asked to describe this picture. Based on the description of this picture, we can identify whether the person might tend to have the signs of dementia or not. I'll explain you in a way. Supposingly, if a normal person tries to describe this picture, the normal person would grab the attention to details, that is, the water is flowing, the child is stealing the cookie jar. However, a person having dementia might not focus on this extreme details, whereas they give a very vague description. Their words are repetitive, their sentences are short. This is a significant difference between how a normal person would describe this picture and how a dementia patient would describe this picture. So we trained a model using a data set, which is from Dementia NetBank, which had this audio recordings of cookie theft pictures. We then did a feature extraction, which is divided into three parts. First is acoustic feature, second is linguistic, third is cookie theft. In case of acoustic features, the pitch, the audio, the deviation from the centroid of the frequency, etc., are all recorded and extracted. In case of linguistic feature, the pause between word, the word count, how many of words are repeated, are there any filler words, as in the dementia patient tend to use more amount of filler word as compared to a normal person. As well as I said, their words are very simple, their sentences are very short, and they miss the attention to detail. And then we have a cookie theft TF-IDF vectorization as well. So this is a list of features which we extracted and the list of libraries which we use to extract them. All these features are being sent to a specific individual model instead of relying on one single model. So acoustic model is trained on random forest, linguistic is on logistic regression, and TF-IDF is on random forest again. So all these base model are then assembled into to build a robust meta classifier that is using logistic regression, which resulted into our test ROC AUC curve as 0.922. The second pipeline which I talked about was timed up and go test. This is also a sort of clinical test which is performed by clinicians and doctors. So what exactly this test is? A patient sitting in front of a doctor is given some basic instruction, that is to sit, to stand, to walk, turn, rotate, to raise the left hand, to raise the right hand. It is observed that when these multiple instructions are given to a normal patient, the patient successfully completes without getting confused. But in case of dementia patient, if you give them multiple instructions altogether, they tend to get confused. Their motor reactions are slower. If you ask them to turn, they'll turn slower. If you ask them to raise their right hand, they might raise their left hand because the way they think, their thinking process and their reaction time is comparatively slower as compared to a normal person. So instead of classification here, we just try to normalize with the help of standard values. So if a person has the standard values, if recorded values greater or less than standard values, we recorded our conclusion as per that. So this is the standard ideal values which is recorded for normal person of different age group, like the time to stand, time to sit, time to walk, or time to turn. So if the recorded value is deviating from these ideal ranges, then it is noted to the clinician. However, it is not concluded about having dementia or not having dementia. So this is just an assistant tool for the clinicians and doctor to automate this test, so they don't have to be physically present at the center. The patient can even take this test at their home. Also, one of the biggest advantages of this test is this test is usually performed using high-tech sensors, which are very costly. However, in case of rural areas, in case of poor network connectivity, uh, the people there won't be able to afford these tests. So we try to automate it for them. The tech stack which we used was scikit-learn for model training, that is random forest logistic regression. We used assembly AI for our speech translation, and a YOLO model for which detected 33 key points, as well as an XGBoost model for TUG mobility classification. So this is a stat ensemble model, which is a test model which had accuracy of 0.89. This is so concluding, our main aim was to build a basic screening tool, which is low cost as well as scalable, and to build two different pipelines, that is speech and mobility all together. As ensemble models showed, if we individually considered all the three features, the contribution is less. But if we combine them together, they actually provide the result with a greater accuracy. And our future scope is that currently our cookie theft explanation, that is our audio transcript, is limited to only three languages, that is English, Hindi, Marathi. So in future, we might include many other languages, as well as we can also incorporate wearable devices like smartwatch for our sensors to provide our TUG monitor. That's it from my side.
Yeah, Shravani, it was a brilliant presentation. The concept is also innovative, but the concern is regarding the response time given by the user, or everything is depending upon the user's speech and his motions. So,
Yes.
in order to deal with that, how your system is tuned?
So we had did a normalization when we are recording the speech, as well as cleaning. So even if there is noise or anything, it is eliminated to a good extent. Hello?
Yes,
Hello?
yes, yes. Perfect. Yeah. I got that. Second thing I would like to ask you, when it comes to readily available data set, if it is not been recorded under the normal circumstances, it might be having some noise, etc. Acoustically, it should be having voice of multiple people. Then in that constraint, how you're going to tune?
In case of that constraint, focus on the pitch. So the voice which has the highest pitch is considered to be the voice of the patient, and rest other pitches which are below that are muted.
Consider as noise, right?
Noise, yes.
Okay, perfect. Okay, no issues. Good one.
Thank you.
Okay, fine. We will go with anybody who is pending, the last one.
Yes, we have Vidya Raj with the paper title Deep Learning Based Automatic Attendance System using real-time face recognition with CNN FaceNet.
Hello. Yes, ma'am.
Ma'am, you may start presenting, but kindly be quick with your presentation.
Yes, ma'am. Yes.
Thank you.
Let me present my screen.
Yes, ma'am.
नहीं present हो रहा. Ma'am, there is no option for the present screen option.
Ma'am, the permission has been given for sharing the screen to all the presenters.
No, in my screen that is not option. There is no option for screen sharing.
There would be an option in the bottom which says share with a box with an arrow.
No, there is no option. Only
You
participate
can
chat.
rejoin. You can rejoin and check. Be quick.
Okay, okay. Just a moment, sir. Just a moment.
Was she able to reconnect?
I'm not sure, sir. But can we have Anjali Baba Sahib Darandale with the paper title Design Implementation of Smart Cert, a secure academic certification verification system using blockchain technology. Dear presenter, please be quick with your presentation.
Yes, ma'am. Yes, ma'am.
Anjali, do one thing. You should just show me your architecture and the conclusion. Based on
Yes,
that,
yes,
we
ma'am.
will have. Yes, please show me that.
This is my system architecture, ma'am.
Go make it full screen. Make it full screen.
Yes, ma'am. Yes. This is my existing system, ma'am. In this system, the university first issue a digitally signed certificate to the student. The student share the certificate with the verifier, and the verifier use the university public key to verify the digital signature. If the signature is valid, the certificate is genuine. Otherwise, it is considered fake. Then
Okay. Got your idea, Anjali. Got your idea. Go to the conclusion part.
Yes, ma'am. Yes. 1 minute. Yes, ma'am. This is my conclusion. In future, the system can be integrated with blockchain for decentralized certificate storage, mobile applications for instant verification, cloud-based deployment for large-scale access, and AI-based fraud detection to identify suspicious certificates automatically.
Okay, fine. No issues. Good one. No issues at all. Just only one question I have. How to verify any fake document is being scanned? For example, I would just incorporate whatever idea you have done and embed that to a fake document and pass to your system. Whether your system will detect it is a fake one.
Yes, ma'am. I use a QR code QR code, then digital signature. I'm generating unique hash value to instant verify this is the certificate is fake or real.
Okay, fine. Okay, fine.
Thank you, ma'am.
Thank you so much.
Thank you, ma'am.
Thank you. Vidya Raj, if you can
Yes,
come
ma'am.
to the presentation now.
Yes, ma'am, please. I am presenting my screen.
Okay.
I guess she is again facing some difficulty regarding the sharing of screen. So what we'll do,
No, sir,
we will.
just a moment. No, sir, just a moment. I'm sharing my screen.
Yeah. Now your screen is visible. Just show me your architecture and then you can move to the conclusion so I can get the idea.
Yes.
Okay, again that attendance management system. Fine.
Yes. Yes, sir. Is it visible now?
Yeah, it is visible.
Yes,
Show
ma'am.
me your
Yes. So good.
show me your architecture.
Sir, within 5 minutes, I will complete the presentation.
Mm,
If you allow me, within 5 minutes, I will complete.
yeah, we can get the idea from the architecture itself. You can start from the architecture and end to the conclusion.
Okay, so good morning, all of you present here. I am Vidya Raj from Marwadi University, and these are my co-partners, Shailja, Kifita, and Shushma ma'am. So we built a fully automated contactless attendance system using deep learning, where no manual roll calls, no specific hardware, and it worked like in real time. So let me show you why does it matters. So manual attendance will waste 5 to 15 minutes of time for each sessions. Has 3 to 8% error rate is also there, and it can be defected by proxy fraud. So existing system that we have built in the literature are either inaccurate, either contactless or end to end. They don't close the loop from face to attendance record. So we solve three problems in one particular system. So this is my system architecture. The first thing is capture, detect, embed, recognize, and log. One pipeline has 5 stages, all running end to end in 38 milliseconds per frame. A standard HD webcam is there, which feeds into MTCNN for multi-phase detection. Detected faces go to FaceNet, retained on 3.3 million images, which produces a 128 dimensional embedded fur face. An SVM classifier matches that embedding against our student gallery, and then a confirm match triggers automatically CSV logging with a timestamp and live dashboard updates instantly. So no manual step, fully automatic from camera to attendance record. The methodology and data set. To evaluate our system, we use two data sets. The first one is ORL and AT&T Face Database, a standard academic benchmark with 400 images of 40 subject covering a variation in expression, lightning, and slide pose. And the second data set we use that is collected by ourselves itself. That is 1000 images of 10 students across 3 lightning levels, 4 head poses up to 30 degrees, and 3 expression and partial occlusion with the glasses. So both the data sets were split in 70, 70, 70, 15, 15 for training, validation, and testing. Now we capture our system against three baseline, uh, um, LBHP and VGG phase, representing fully from traditional handcraft features to deep learning. Uh, Next is results. So on the standard ORL benchmark, 98.9 recognition accuracy, that's 3.1 above VGG phase and 14 points above 18 phases. Agent faces. But accuracy alone doesn't make a system secure. Our false acceptance rate is 0.6%, virtually no unauthorized access, and equal error rate is 0.9%. On our real world classroom data set, varied lightning, 30-degree head poses, glasses, we are achieved 96.7%. Even in the absolute worst case condition, uh, we outperform this LBPH by 18 percentage point. So all of these are 38 millisecond per frame and 26 frames per second live. The Yes. The real So every prior automated attendance system in the literature is either less accurate or not end-to-end or both. The closest prior work reports 97.2, but that is detection recall only. No recognition accuracy, no attendance logging. We deliver 98.9% recognition accuracy and complete end-to-end operations. We are the only system in the comparison which do the both things. Now let's move to the conclusion part. Yes. In 98.9 best in class recognition accuracy, 38 millisecond. That is the genuine real time at 26 frames per second. Zero force acceptance in live pilot deployment against spoofing. This is not a benchmark experiment for us. It is a deployment system. So thank you so much, sir. Hello.
Okay,
Thank
Vidya.
you
It
so much.
was yeah, Vidya, it was good presentation. Just one question. What is the error rate? Means detection of false face.
Sorry, ma'am. Which rate?
Yes.
False.
Error rate.
Yes.
Detection of false face, etc.
Yes, the error rate was 0.9% in our case in the system. As I have mentioned into the PPT, it is 0.9%.
Okay, okay, quite good one. Fine. All the best.
Thank you so much, ma'am.
Thank you so much for that presentation. I would sincerely like to thank all our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 11th version and all the previous 10 versions of the conference. We will be happy to have you in the 12th version in 2027. All the presenters would be getting their digital certificates through email within 2 working days. This publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2026. I would also like to thank our session chair, Dr. Yogesh, and thank you so much for chairing this session. A token of appreciation from the to the chair of behalf of Team ICT 4SD 2026 and Global Knowledge Research Foundation and partners. Thank you so much for your valuable presence, sir. Anything you have to say before we end the session?
Thanks. Thanks for the conference. I have good experience. We have lots of participants who are various parts of it was a really nice presentation. People are working on such good variety of topics. That is very nice. So I wish them all the very best. And thanks again to ICT organizers for giving the chance of sharing this session. Thank you. Thanks a lot.
Uh, Now, can we have everyone turn on their cameras for a quick virtual snapshot? Thank you so much, everyone. Stay safe and take care.